Hey, AP Chemistry. I'm picking up on page 6 of the covalent bond notes. That being said, this next one that we're about to go over is not on the AP exam, so if you don't want to confuse yourself, you don't have to watch this one. And some of the vocabulary is the same, so make sure that you know the one that's going to be on the AP exam. It's really good to go back on your little cheat sheets, so I think that y'all creating handwritten notes of what you know, like summaries of like kinetics and gas and bonds and all that stuff, to where it's really easy to find to trigger your memory is going to help you out a lot on the AP exam. Since it's open note, you might as well prep your notes for that. That's what I would do if I had an exam in college that was open note. I made myself a little cheat sheet, a quick guide to what I know to try to help me find equations quickly, which you have an equations chart, but some equations aren't on there. So it helped me find equations quickly. It helped me find common structures or concepts or values quickly. And so that way you can have those things to look at. So I would put the old stuff on, and so make sure that you don't review this part for the AP exam. But to just kind of let y'all have a better understanding of chemistry and help you understand the workings of molecules, this hopefully ties some things together for you. So this is the molecular orbital model, and then it is going to explain some things that haven't been explained or tie things together. And so there's 4 points, and the 4 points are that electrons are not always localized as in the Vesper theory, therefore resonance must be added and explained as best as possible, which we've talked about resonance a little bit. Molecules containing unpaired electrons are not easily dealt with using the localized model. So those molecules that have electrons like, I'm sorry, I don't know what's going on. It's like noon. That like water that have the 2 unshared pairs of electrons on the oxygen, it doesn't account for them as well as some of these other models. But that's just to help you understand what they're talking about, the unpaired shares. Water's pretty well known and the structure's pretty well agreed upon and everything. So actually I don't know if anybody disputes it at all. Magnetism, so different things, magnetic fields, flowing, magnetism, things are magnetic, and this kind of explains it a little bit better. Bond energies are not easily related using the localized model, and so this is going to help us understand things a little bit better. So that's kind of why we're going to go over it. We're just going to hit some terms that you need to know in this video, and then in the next video we're going to start to apply and give examples of them. So there's the bonding molecular orbital, an orbital lower in energy than the atomic orbitals from which it is composed. So remember our orbitals, we have an s, p, d, and f orbitals, and so we're talking about lower energy levels. And then anti-bonding molecular orbitals would be the opposite, it's higher. So an orbital higher in energy than atomic orbitals from which it is composed. And there's a diagram, and consistently throughout these notes, they're going to be using A for anti-bonding and B for bonding. So when you see drawings and it has A and B on it, it's referring to these two vocabulary terms. So make sure you understand those to look at those diagrams if you decide to move on with these sets of notes. Bond order, we've talked about bond order before, so this would be one of those ones that I don't want you to get confused with. The difference between the number of bonding electrons and the number of anti-bonding electrons divided by 2 indicates bond strength. And bond order always indicates bond strength, right? If you have a higher bond order, it's a higher bond strength, so that's still consistent here to make sure that we understand that. Homonuclear diatomic molecules, so homo means same, so those composed of 2 identical atoms, so the same atoms. And then heteronuclear diatomic molecules, those composed of 2 different atoms. Paramagnetism, which is what they're talking about up above in part 3 where it says the reasons why, causes the substance to be drawn into a magnetic field associated with unpaired electrons. And then diamagnetic causes the substance to be repelled by the magnetic field associated with paired electrons. So we have some repulsion and things happening with magnetic fields that will be described. Then at the bottom it says general energy level sequencing for filling orbitals using the molecular orbital theory. And so you can see it says a sigma for that 1s2 and another sigma for your 1s2, And then the little stars are anti-bonding. And then sigma for 2s2, sigma. And then we have pi bonds that are starting to form, and that's pi x, y, and so on and so forth. So that being said, you can look at that, and then we'll pick up on the top of the next page for the next one. So hopefully that's kind of making some sense. Again, you don't have to watch these if you're getting confused. Stick to the stuff that's going to be on the AP exam. If you're wanting to know for your knowledge, then here's a video for you.